Hello, welcome back to the channel. So let's continue our previous video and solve one more question on calculating indefinite integrals of a combination of trigonometric functions. So in this case, in this question, we have to calculate the integral of secant to the power 8 theta times tan to the power e theta d theta over here. So at first sight, this expression may seem complicated, but if you know the correct approach on how to approach these type of problems, you will be able to easily solve this problem very quickly. So let's start calculating the indefinite integral over here. But before calculating that, in order to identify the pattern, in order to get the full idea about how we find patterns in these type of questions, I will highly suggest you to first watch my previous videos in order to get the complete idea about how we identify patterns in these type of questions and then solve them by identifying those patterns and using the correct approach in order to solve for these type of questions. So in this question, we'll again use substitution because we see a secant theta expression and a tan theta expression. So it gives us an idea that this question might be solved easily by using substitution because we know that the derivative of secant theta has a tan theta component, and so is the case with tan theta, right? The derivative of tan theta also has a secant theta component, right? So that is why, since we have the function and also the derivative of that function in some form or the other, it gives us an idea that it would be easier to solve this question using substitution rather than following any other approach that we discussed or learnt in the previous videos. So in order to solve this question, we'll again also use one more property. Since we know that sine square theta plus cos square theta equals to 1, you can also derive this expression over here. You just have to divide the whole expression. So if you have sine square, you know that sine square theta plus cos square theta equals 1. So if you divide the whole equation by cos square theta, this will become tan square theta, this will become 1, and this will become secant square theta, right? Because 1 by cos square theta is secant square theta, which you have on the left expression, and this, when you divide the whole expression by cos square x by cos square theta, you'll get sine square theta by cos square theta, which is tan square theta, and cos square theta by cos square theta, which is 1 over here. So you don't have to remember all of these identities if you know how to convert this identity into this form or the cosecant square theta form as well. You just have to know this expression, this trigonometric identity over here. If you want to derive the cosecant square theta identity, you'll just divide this whole equation by sine square theta in that case, right? So we'll use this property that secant square theta is 1 plus tan square theta in order to solve this question. And now, since we identified that we'll use substitution in this case, there are two options over here, right? The first option is to take u equals tan theta, and the second option is to take u equals secant theta, right? So we have two options based on the functions given in the indefinite integral. Either we can go with u equals tan theta or we can go with u equals secant theta. But when you'll go with this approach, when you'll try this approach, you will see that if you try this approach, if you do substitution using this approach, you'll make your indefinite integral even more complicated than the original expression over here. But if you'll go with this approach, you will make your integral expression a bit simpler than your original integral expression. I would highly suggest you to first try calculating the answer to this indefinite integral using this approach, and then you'll clearly realize that if you use this approach, you would be leaving some important terms in this expression which you would not be able to substitute using this assumption over here. And also feel free to comment down in this video if you didn't quite understand why we didn't go with this approach over here. But the basic idea is, if you consider your u to be secant theta, your du would be secant theta tan theta d theta, right? So if you would go with u equals secant theta, this would be converted to u to the power 8, but you would definitely not have a clear approach on how to use substitution in order to change this expression over here, tan to the power e theta expression over here, by using this scenario over here, right? So that is why we'll go with u equals tan theta. But again, if you have any questions regarding this approach, feel free to comment down in the comment section below. So we'll go with u equals tan theta, and we know that if we take u equals tan theta, our du is basically secant square theta d theta, right? Because the derivative of tan theta is secant square theta. So now let's write the integral expression again and visualize what we will be doing in the substitution over here. So we have the integral expression as secant to the power 8 theta tan to the power e theta d theta over here, right? And here we assumed our u function to be tan theta, and du would be then secant square theta d theta over here. So let's have a secant square theta d theta term first in order to clearly see what's happening in our substitution over here. So we can get the secant square d theta term by splitting this secant to the power 8 theta, right? This can be easily written as secant to the power 6 theta tan to the power e theta secant square theta d theta, right? If we convert this expression by splitting this secant to the power 8 theta into two terms such that we have a secant square theta d theta, this will be basically secant to the power 6 theta times secant to the power 2 theta, right? So now we have a secant square theta d theta term over here, which can be easily substituted to du. Tan to the power e of theta, since we are taking u to be tan theta, we can easily convert this expression as u to the power e, right? But now the only thing which is remaining is secant to the power 6 theta, right? But since we know another trigonometric identity, which we already proved in the first half of the video, we know that secant square theta is 1 plus tan square theta, right? So now since we want this expression to be in terms of tan theta only, we will convert this secant square theta by using this identity over here. So in order to again simplify this term, we can write secant to the power 6 theta as simply secant square theta to the power cube, and then the other terms would remain the same, right? Tan to the power e theta secant square theta d theta over here, right? And now we know that secant square theta is basically 1 plus tan square theta over here, right? So secant square theta is 1 plus tan square theta to the whole cube. Now tan to the power e theta secant square theta d theta over here. And now the substitution is very simple, right? You will just convert every occurrence of tan theta as u, and your secant square theta d theta will be changed to du over here, right? So this expression over here will be easily changed to 1 plus u square to the power whole cube, u to the power e, and then secant square theta d theta is du over here, right? And now in order to solve this integral, you can basically expand this cubic expression, and then you will be easily able to calculate the answer to this indefinite integral over here. And if you'll calculate the indefinite integral over here, your answer will be in terms of u. But since your original integral was in terms of d theta, you'll have to convert again every occurrence of your u in your answer to tan theta again over here, right? So I would leave the integral calculation to you, and I would highly appreciate you to comment down in the comment section below the answer to this integral and also the answer to the original expression over here. You'll just have to substitute u equals tan theta in the answer to the indefinite integral that you'll calculate over here. So that's it for this video. Again, the main takeaway from these type of questions is that whenever you have been given a combination of trigonometric functions and you have to calculate an indefinite or definite integral, you basically have to spot a function, a trigonometric function, and also see if the derivative of that trigonometric function is also present in some form or the other in the same integral expression. So if that is the case, it will basically give you an idea that it would be easier to solve that integral using substitution than any other method that we used in the previous videos. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.